Okay, I'll say this one more time because we had somebody that was absent earlier when I said it. This is the last day of new material. We're going to still be reviewing stuff that you haven't seen in forever. But this is the last day of new material. We have a couple days of review and then a test on this logs unit. And so just, I can't believe, but here we are at the end of May, last day of new material. So let's get to this slide right here. Nope, not that one. Not that one. This one, the one that's got a little target on it. Okay, so it says solve for x in the problem where there's an x in the argument. We've done that before. This is the same exact learning target we've had before, but they just get trickier. So let's talk about the kind that get tricky. Remember that the base has to stay positive and also can't be 1, and the argument can't be negative. If the argument's negative, the thing doesn't work. So one of the trickiest things that happens is we end up getting 2 answers and one of them's negative. You know, we've solved this log problem down. Let's say we had we get this thing solved and we end up with 2 answers, and let's say after all of that work we get x equals -5 and x equals 2. Do you remember this deal where if I take the -5, put it back in the problem, and it causes it to fail? That can't be allowed then? It's called an extraneous answer. That's one of the tricky things that gets you. Okay, so watch out for all your answers, that if you plug your answers back in, they can't make the argument or the base negative. That's one of the things that'll get you. Another thing is just forgetting basics like, can you have a 1 here or can you have a 1 here? And I'll give you a tip. One of these doesn't exist and one of them's fine. Do you know the difference? Nate, what do you think is the one that actually exists?
The one that uses the one with the 1 in the
Yeah, that one exists, and what's the answer? 0. This one does not exist. Can't have a 1 in the base, right? So I had this dumb little saying, if you won the argument, you get nothing, you get 0. But that's different than not existing. This does not exist because you can't have a 1 in the base. All right, let's move on to this page right here. This will be page 6 of your notes. And I also made a statement at the beginning of this unit that said, if you can condense 2 logs into 1, that you should. I can't think of a time when it wouldn't help. It always helps to condense them. So let's condense this down into 1 log. So everybody rewrite that as just 1 log. Do you remember that deal where if you're subtracting them, you do one thing? And if you were adding them, you do something else? Totally, we're subtracting them, so I use log base 7, and then what? 5 divided by 3, very good. And this one comes down and it's log base 7 of x. Next little rule about logs is that if this and this are the same, then this and this have to be equal. So I'm going to not cancel those logs because there isn't a mathematical reason to cancel them. But I can just ignore them and say 5/3 has to equal x. There, I'm done. I got x alone. The way you can tell you're done is if x is alone, and x is alone. So now I should be sure that I didn't mess something up. Can I have a 5/3 right here? Yes, I can. That's a positive number in the argument. That's legal. It's all good. All right. So if you got logs that have the same base on both sides, you can ignore those and go right for the arguments. That has to equal that. All right, another one that comes up a ton. Well, actually, let's do this first, and then I'm going to show you one more kind of log that comes up a ton. The power rule has to do with making something into a power. Did you catch that 3 could go up there? That was the key moment here. And now, if these are the same, then I can concentrate on that has to equal that. X equals 2, done. So you can't do that with this 3 here. You have to move the 3 up here, and then you can ignore the logs and just set that equal to that. And I forgot the 3. Oh my gosh, I didn't copy it down. Good. That was the whole point of the problem, is you got to move the 3 first, and now the 3 is on the 2. So there we go. So then the answer is actually 2 to the 3rd, which is 8. Oof. Now I should actually be sure that that's right. So I go back and I put it in. 8 goes here. And log base 5 of 8 is supposed to be a log base 5 of 2 to the 3rd, which is 8. So yay, it works. Okay, I want you to go off to the side for just a second and write this. Log base 2 of x minus 3 plus log base 2 of x plus 4 is equal to log base 2 of 1. Okay, fact. If you have 2 logs, it's better to put them together into 1. So whenever you can condense it, you should. So you condense it to log base 2, x minus 3, and that's a plus, so we go times x plus 4. And it equals, didn't we just talk about this one? What is log base 2 of 1? 0. Remember that deal? They always say, and simplify. So if you're going to be solving this thing and simplifying it, that is definitely simpler to say 0 right there. Now, you don't have to, though, because you have log base 2 on both sides, but you're going to see it's going to work out to the same thing either way. 2 to the 0 equals all that. But wait a minute, what is 2 to the 0? What is 2 to the 0? Don't overthink it. It's 1. So 1 equals x minus 3, x plus 4. Is this that kind of deal where you can just say x equals 3 and x equals negative 4? Is that a correct answer? No, that only works if this equals 0. And it doesn't equal 0 anymore. I know there was a 0 there for a second, but when we rewrote it to get rid of the log, it was 2 to the 0, which is 1. So, no, it's not just these 2 answers. So what do you do? Well, you're faced with this. This is one of the trickiest things as kids get stuck in their quadratic solving. It isn't that hard. You just got to remember to set it equal to what? To what? To 0. So get this multiplied out. And then it'll be 1 equals that. Garrett, what'd you get when you multiplied it out?
Plus 4x
Yep,
minus 3x
yep,
minus 12.
good. And then you put these 2 together. And you get x squared
Plus x.
plus x minus 12. And then if really, really want to factor this again, but that's dumb because it was already factored in the first place, so no point in that. Subtract 11 from both, or sorry, 1 from both sides, 0. Now, in honors, even though this wouldn't factor, we would expect the kids to finish it. How the heck do you finish it if it won't factor? Say it. Yeah. X equals negative b, negative 1, plus or minus the square root of b squared, which is 1 squared, which is 1, minus 4ac, 4 times 1 times negative 13, all over 2a, which is 2 times 1, which is 2. And it's not that hard as long as you remember that you got to kick into the quadratic formula. And 4 times 13 is 52. 1 plus 52 is 53. And there you go. There's your answers. Now, if you really want to be hardcore, then do you get that x in this problem can't be negative? Know what I mean? Now, we would never give you one that hard because this is not the honors class. But if you were in the honors class, you would have had to also catch that this has two options, and one of which is -1 minus that, which is a fairly big number. So your answer would be negative. And you'd have to rule that one out. So that one doesn't exist. So that one would be no solution. So that one would be an extraneous solution. So we'd cross it out and say it was extraneous. Now that's too hard. We're not going to have anything that bad. But do you think we might have some where they would factor? Yeah, you've seen it a million times. So expect that. All right, so big picture. You condense the logs first. And if you can simplify stuff like this, you simplify it. So let's go to this one. Condense it first. It's very similar to what we just did. We're actually almost done. Today's a short day. Just gotta show you a few more weird things that can happen. These two condensed together. Riker, what did you get? Log base 3.
X times x minus 2.
Yep. Now, if there was logs on both sides, we could just ignore them, but there isn't logs on both sides. George, I'm stuck. What do I do?
Really like the same one, that same thing as you did in the last problem.
So,
Pick the base
yes, 3 to the,
first,
yup, equals,
x times x minus 2.
yep, that's exactly right. Now again, 3 to the first is 3, so that's really simpler than that. It's just that. Can I just say the answers are 0 and 2? No, that's if it was set equal to 0. But it's not set equal to 0. So how do you solve a quadratic then? Take a second, everybody. Multiply this thing out, set it equal to 0, and I hope it factors. Because if it factors, if you can factor it, you should. And it'll probably work out really nice. We make almost all of them factor. It isn't that scary. If it didn't factor, you would just use the quadratic formula. But either way, you got to get it equal to 0 first. Now, I know at this time of the year, it gets harder and harder to help kids concentrate. Like, you know, like it's harder and harder to concentrate. So we're going to have more work time than normal. And I hope that you're willing to come up and ask. Would be really nice to finish strong with one last A on your regular testing. I'm warning you, the final is hard in this class. Like, we were talking about the final, just a bunch of the pre-calc teachers this morning. So it's not easy. So you're going to want to have a little cushion going in your grade so that if your final doesn't go that good, you still keep your decent grade that you have right now. All right, so x times x is x squared, negative 2x. Hallie, what do I do now? Yep. 0 equals x squared minus 2x minus 3. And I was not bluffing at the beginning of the year when I said you have to factor in this class or you're not going to pass it. So, should factor pretty easy. I see a negative here. I use a plus and a minus. And then how do I make a 3? It's got to be a 3 and a 1. But I'm more careful now about where I put my 3 and my 1. I don't just slap them in. I know I want negative 2x, so I want the 3 to be negative. Now, if you don't get that, you can always just try it and see what happens. 1x, negative 3x. I did it on purpose so it would come out to negative 2x. Cool. Would you please talk to the kid next to you about what you think the final answers are for this one? Iris, what do you think? 3 works. Then what? It's extraneous. If you put it in here or here, either one of those spots, it wouldn't work. So it's out. Nice. All right. We're on the second to the last page already. Time's flying. Condense this puppy. Claire, can you tell me how you condense these two?
It would be log base 7x plus 1
Yep. And then, Addie, what do I do now that I condensed it? Don't multiply this out yet. Yep, so I take this 7 and put it to the 1. This is called, I call it a rewrite. You're getting rid of the log by doing this. 7 to the 1 equals all that. And notice the log is gone. I've had kids ask before, what happened to the log? Well, we took it out of log form. It just isn't a log anymore. Once you rewrite and you make the base, go over the other side to that power and come back here, there is no log. Spencer, next step. Okay, x squared plus 1x minus 5x minus 5. And there's a 7 there. Multiplied it out. Mason, next step.
Minus 7.
Yep. And we can combine these two also as we're finishing up. X squared minus 4x minus 12. Ooh, 12s are nice because there's lots of factors. So it's likely it's going to factor. Jack Sexton.
X minus 6 and x
Plus 2. I bet he's right. Negative 6, positive 2. Put them together, you get negative 4. Sweet. Answers are x equals 6 and x equals negative 2. And then you move on to the next question, and then you're like, oh, crap. Yes, that's negative. And so is it automatically extraneous? Actually, no. You got to go check. But it is extraneous because I checked. Look, it makes the argument negative. Can't have that. I don't even have to check the other one. If it makes one of the arguments negative, it's out. So, boom, it's out. There's your answers. It's still an answer. It's just called an extraneous answer, and I don't need to make you spell it because I'm not sure even myself how to spell it. I mean, I could probably figure it out, but it would be painful. So, EXT is just fine. All right, the last melon. I was very tempted to go like this, and I bet a few of you did. Why is it not that? Because that was a minus. So it's a divide. Now, it's the last problem. It's gonna be hard, but it's not impossible. My number one rule is if you can factor it, you should. We've already used that like 3 times. My number 2 rule, I'm gonna have to get like Server's rules of math and put them on the wall. Number 2 rule is clear the fractions. There will be fractions. So, if you're just stuck, you should be thinking, anytime you're just stuck and you're like, I don't know how to clear I can't really multiply by x minus 2 on both sides here yet. So I don't know what to do. Whenever you're stuck, think about a rewrite. 4 to the 1 equals all that. And 4 to the 1 is just 4, so. Okay. And this is where, again, the people that have got their algebra skills down and know how to clear the fractions out are like, it's no big deal. And those of you that have not mastered your basics would be like, I've never seen anything. Well, you have, but I don't remember what to do on this. You multiply by x minus 2. And that cancels that. Don't look at that phone. We'll be done very soon. You can look at it all you want. I think it's 9 halves. Did anybody else get 9 over 2? A bunch of people, yes. You beat me. That's impressive. Should I take a second and check it? Well, just to make sure that it doesn't make something negative. So like if I put 4.5 here and there, either way, I'm not going to make any of the argument or bases negative, so it's good. The end. And that means from this moment on, it's all just review. Review for the rest of the year. That's amazing. So a little bit of review, and then we take a test. Right now, the plan is the review is tomorrow, and the test is the next day, Wednesday. And then Thursday, I'm going to run you through an intensive top 20 final like push to try to get kids to completely master that thing. And then Friday, we'll take a top 20 again, except this time, it's going to count for a lot of points. Either I'm going to put it into the summative category, or I'm going to put it into the formative category, but for like 100 points or something. Like it's going to be worth a lot. So you need to master your basics. We've been working on it. You know, I've given you that thing a million times. This is your chance to get it fixed. By Friday, we're going to have to master that. So I'm just going to give you one of those to end the hour. Just tell me, this comes up on the top 20. Mark, have you done enough of these by now to know what to do?
You clear the fraction.
Yeah, so what do you do?
Multiply by 3.
Multiply by 3. Why did I just do it wrong? It's really common to do what I just did. Yes? I skipped the 2. Or you could have subtracted 2, but it actually wouldn't have been smarter to subtract the 2 first because you'd have to do a fraction minus a whole number, which is a pain. So you weren't wrong. I could subtract 2 first, but I was forgetting to multiply the 3 by everything. See, that one has to be distributed. Distributed to both terms. So then this is 3/4. You should know that that's really like 3 over 1. So the 3 only gets multiplied on top. And then it's still got a fraction in it, which is a pain in the butt. Clear it again. Times by what? 4. 8n plus 24 equals, those cancel, 3. And then it's just a 2-step equation that you've been doing since literally middle school for some of you. You just subtract 24 and you divide by 8 and you're done. So I just wanted to remind you that it's probably the most missed top 20. Second place to that is kids get confused on what you do on this kind of question, because they forget, is this the kind where you multiply the powers? Or is that the kind where you add the powers? And in this case, you multiply those powers. So this would be 2 squared is 4. A to the 8th, B to the 6th, and then you times by B to the 8th. And this is the kind where you add them. 4A to the 8th, B to the 14th. That's probably the second most missed top 20. So I'll do a little bit more brush up on that on like Thursday, and then we'll take that big final top 20, hopefully. If it's good, it can be your last one on Friday. And if it's not good, you may want to retake it because it'll be worth a lot of points, and you want to retake it. I'll allow retakes on that. Yes?
When's our test for this unit?
This unit's test is Wednesday, so literally we've finished everything from this unit. So tomorrow's a review, test Wednesday. Thursday's another review, but for the top 20. Test Friday on the top 20. And then the next week after that, all finals review. I give you this giant packet of like what the test is like, and you work through that with me. And then we take take the final on the normal day. The seniors, they actually, there's not many in here, but in one of my other hours I got more seniors. They might want to start reviewing for the final on Thursday and Friday of this week, because their final happens on so the seniors, listen up, on the 30th and the 31st of May. So in class, you'll take it one part on the 30th and the other part on the 31st, because normally seniors, normally finals, you get 2 hours for the test, so you get to have 2 class hours to take the test. So that'll happen again for my few seniors I do have in here on 30th and the 31st. So I'm going to hand out the review packet so that the seniors can get a head start on it if they want to. On Wednesday, after you've taken the test, I'll hand out the review packet and you can start reviewing for the final. All right, that's all I got for you for today.